tablets and things here, so don't mind me. Um, One thing I forgot to do while I was setting up. Uh, 1 second while I mash passwords. Oh, and refresh pages. How do you refresh on Chrome? Oh, Safari. There we go, Safari. Had to refresh some stuff on Safari. Hi, hey, what's up? So, I'm the founder of the Lift and Shift Foundation. I'm here for my STEM steam engine tonight. I've had a few projects, and I think tonight I'm gonna finally like plug stuff in and make it work and make it happen. It's spring. It's been hot and cold here in New York City, so my throat is really dry and kind of crazy. I'm gonna probably have lots of water tonight. Excuse me, and I'm here a little early because I got wrapped up early with some of the projects I was working on today. But let me check and make sure we've got audio for you. Yes, I see some audio. So I've got a bunch of screens up here, and I've covered up our Battle of the Bots logo because tonight is not Battle of the Bots, and I'm trying out new things. I'm trying out new stuff. So what you see there are two different screens. I'm connected all around here with a Teams meeting. So my regular phone, my day phone, is a Teams meeting right now, and the video looks great. I love the video. The resolution looks so much better than Zoom, better than Meet and things. I'm really impressed with it. But so that's one view. The other view is my other phone, my old phone. It's a Pixel. It usually is running a server, a print server, my 3D print server. If you've ever seen Octoprint, that's the server that's running, and it's running right now. So I might be able to open that and actually share that today. But we're gonna try to turn on my laser, use the laser cutter. We're definitely gonna fire up this thing on my desk right here on the very top screen. So over the last few weeks, we've been building this. It's a surface mount solder station. We're going to use it to reflow some circuit boards, and I'm going to test it out today. We're actually going to try it. I did not grab my non-contact thermometer, laser thermometer. I have a laser thermometer, so that's what I'm going to use to kind of adjust the temperature to get where I want to get it. But we're going to try soldering a couple boards together, and hopefully it turns out really, really well. That's the goal. But we're going to get up close on it if we can, and see if we can make make that happen. But usually on Thursday nights, it's a short night for me. This is kind of like my Friday. I'm here for, I don't know, 45 minutes, maybe an hour. And today we're going to try out this device that we've been working on. We disassembled this iron here, which you can see up there. My hands are up here. We disassembled this iron, this like travel iron that I had, and we took it apart over the last few weeks, found out how it worked. We 3D printed this mechanism, this new base for it, but also a mechanism so that I can adjust the thermostat on the side right here, and it actually works. You can't hear it, but it's clicking right there. So we're gonna turn this on and actually get it fired up right now. I'm gonna let it heat up a bit. We're gonna plug it in. I'm going to plug it in right now. We're going to let it heat up and see what happens with it. I'm going to be very, very careful with it. We have a new, so we have and I say we, I mean anybody who may have watched over the last few weeks, we redesigned this so that it's safer, so that there's some safety in mind. And I haven't printed the new safer version of this mount, this plate yet, but it comes up higher. It comes up higher, and things are shifted around a little bit so that the bare wires here are not as exposed. It's a safety factor involved, and it's something I feel better about as an engineer, that bare wires are not exposed, especially as I'm like here on the desk, like throwing soldering irons around. But yeah, so let's set that down on the desk. I'm gonna run this cord. I'm gonna run this cord around my legs and things. We're just gonna make it super awkward for me. It'll be like a little obstacle course. That's super cool, right? Super awesome. Let's get it fired up quick. There we go. Okay, we got it plugged in. And you can see the light is on. Check it out, the light is on. So this thing is running and it's hot. Ooh, and it is already heating up good. Yes. So the theory behind this iron, oh, it just turned off. I think it is as hot as it's gonna go right now, unless I adjust the thermostat. So let's try to adjust the thermostat. I'm gonna spin this thermostat. There we go. And the light came back on. You can't see that on your screen. So let me check it out. Let me show you. Let me show you up here. See the light is on? And the light is off. I'm going to hold it down here so you can see the light come on. I'm going to flip this around the other way. Ready? So as I turn this dial right here, it turns on the thermostat a little higher. And if I turn the dial the other way, little hard. I'm being ginger with it. And my fingers are probably wet from the glass. So there we go. So you can see this works. Dun, 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 dun. But I don't know what the thermostat is. The original had a dial on it, so we're gonna have to use my non-contact thermometer, which I use for the 3D printer bed, to make sure that it's working. So we're gonna let this thing heat up. And ooh, yeah, it feels kind of warm. We're gonna let it get nice and toasty. Let's go with like that. I wanted it like 200-ish degrees or so, and we're gonna use it. We're gonna solder together a couple boards. So usually it's surface mount boards, and I actually have these two little boards right here. This one is called, it's a carrier board. It's all surface mount parts on here, and these pins are the connectors that connect the surface mount parts. And I have this Bluetooth module that I really want to start working with. So we're going to today test this out and make it all work. Excuse me. But in the meantime, while it's heating up, that actually went faster than I thought it was going to go with the heating with the heating part. But I'm going to set it at like 200-ish degrees or so. And we're gonna set these boards together. So here's the two boards. Let me see what the other view looks like. Oh, we don't want that view. Let me add another scene. Another window capture. Dun, 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 dun. We're going to grab teams. Poof. And we're going to make this big. Let's just make it big for everybody. Everybody. Like that. You can see that now, right? Yes. Cool. And we're going to slide that back. Maybe. Maybe not. Maybe one more. No, apparently not. No, apparently not. I'm a terrible human being. I should have prepared this better. Wow, okay, so there's some logos. Getting closer. Right there. Bum, ba, ba. Okay, cool. So, let's take a quick look at this right here. There's me, there's the screen and stuff. So this is the iron. It's hot. It's very hot. These are the circuit boards that I'm going to try to solder tonight to test all this out. So this is a surface mount board, and the surface mount means basically that all the parts are on top of the board. There are no holes through it like this. These are through hole as far as a board is concerned, and usually this is what you see with like pins. You're probably familiar if you see like resistors, the little wiggly lines and stuff. This is another surface mount board. Everything is kind of like melted to the top of it, and I'm not going to make one of these boards yet, although I do have some designs for boards like this. This is a pre-bought Bluetooth module. It's a HC05, I think. There's no markings on it, but these pins are all the connectors here, and we need those pins connected to all the little lines right on here like that. So if you can see that, we need to actually solder this together just like that. So we're going to sit this down on this thing, on this iron, on our new reflow pad, and as soon as it gets hot enough for solder to flow, we're going to touch it with this little bit of solder. And hopefully we're gonna have this board working before the end of the night. It shouldn't take long. It shouldn't be a big deal or big process. But yes, so I need to pull out the solder into like a string like that. So we will actually like just go down and touch all the solder. And I have a magnifying glass ready in case it gets crazy creepy. What I should do now is I'll show a couple other things. So how are we going to make circuits and make a circuit board like this? Well, I have a laser cutter. The plan is we're gonna cut stuff up with a laser. Check it out. And this is where I worry about melting stuff. This is a laser, and it's gonna mount on my my 3D printer. This mount right here is designed so that it goes on the 3D printer, and it hooks in, and we're gonna have to set that up and zero it. Basically, zero it. If you are familiar with the military, we're gonna zero it, and it's gonna work. Excuse me. Very much like zeroing a rifle, where we have to learn focus this on a distance so that we can cut things, and this will not be strong enough. This specific laser is not going to be strong enough to cut boards like this. This is a regular standard like through hole board. This won't be cutting through anything like that. But what this laser will do, let me check make sure I got some sound for you. Yes, I do. Okay, cool. So what this laser will do is cut a sheet of plastic like this. So we're going to cut a sheet of plastic like this, and then we're going to use it as a stencil over a board, and that's how I'm going to make the boards. And that's like later. That's like not today. That's like a hi, hey, how you doing? So this like stenciling boards is not a today project. Just this week we got the iron put together. We got the reflow station set up. So I'm going to try it today. The next step in the process I wanted to share while I'm actually here doing it, because it doesn't make any sense to talk about soldering stuff together without how do we get the boards to put them together. Excuse me again, lots of head stuff today. Not COVID. Feels like sinus infection though. That stuffy, congested. But anyway, so what I'm going to do is I'm going to change the view real quick here. I'm going to set up the laser printer or the laser cutter. I'm going to connect the laser cutter to the power so you can see how easy this happens on my 3D printer. And then I'm not so sure we're going to be able to turn it on today. But I'm going to talk about the process of cutting while we check the iron here. I'm going to use the laser thermometer to check the iron for the temperature, because I want it at a specific temperature, about 200 degrees. So we'll check that, and when it gets there, we're going to use this solder to melt stuff together. In fact, maybe I will Google and reference for you. My soldering irons are set at like 60, 70 degrees Celsius, or what is that? 150-ish, 180-ish degrees Fahrenheit. So I think we want this iron somewhere around the 180 to 200 degrees Fahrenheit setting. But let me mash some buttons over here in the Google world. And reflow solder temperature is what I'm going to Google. And the recommendation is 220 degrees Celsius. So that's really high. Those are really high temperatures. 260 degrees Celsius, 210 10 degrees Celsius. Minimum 125 degrees Celsius. So I think we're probably gonna go with we're gonna try a couple different temperatures on here and adjust it so that we can see, because there's gonna be a challenging part. And I'll get to it in a minute. So let's grab the laser cutter just in case we get to it tonight. So I've got the laser, the actual laser right here in my hand. So let's change the view. I'm gonna go over to that laser cutter right there, or that printer, and watch. Check this out. I'm just gonna set this up first. There's a power plug. See that power plug right there? So I'm gonna loop the power plug through. So, and leave it in the back there. I made this so that there's a bunch of lips and edges, and this literally just clips onto. Well, first there's some magnets right here, so these magnets hang on to it, but I wasn't happy with the way the magnet's set, because you can slide it all around and do that stuff. So I made this mount so that it just snaps on and snaps into place. Now I can adjust this laser for a specific setting, and every time I turn this on, we can just tell the printer head to move up. So now we connect this to the fan, which I've already got wired. This was the fun part, but here we go. I don't know if you can see this or not. It'd be kind of awkward if you can't, right? There is a fan cord back here somewhere. There we go. So here's the fan cord. And I'm going to close my eyes just in case, because I don't know if it's on or not. It is not on. But now this laser is controlled by the fan setting for the 3D printer. So we can turn the laser on and off by sending G-codes to the 3D printer. Super cool, right? Well, I'm over here. I'm going to grab my non-contact laser thermometer. I'm back now. Okay, so you just watched me mount the laser cutter on the printer, and it is super easy. It's super easy to do. So what I got here is a infrared. I call it a laser thermometer. It's an infrared thermometer, a non-contact thermometer, whatever you want to call it. But we're gonna test. Excuse me. Our hot. It's a hot plate. It's an iron. I'm gonna call it a reflow station. But we're gonna test it. We're gonna check it out. So I'm gonna turn my you hear the beeps, right? Yeah. So we're gonna turn on my my crazy non-contact thermometer here, and I'm gonna give you the good view here. Yep, let's do that. Let's give you that, so you can see this, right? So there we go. So this is 147 degrees, and we want to go higher, do we? Okay, so here's my dilemma. These boards already have parts on them, right? So this board already has a bunch of parts on it. See them? You can see them right there. That's a bunch of parts that are already attached to this board. And the problem is, if we heat this board up, these parts are all going to come loose and come off. So that's problem number one, right? But aside from that, we want this hot enough so that when we touch it with solder, the solder melts. So we need to kind of find like a happy medium here where we're not removing all of these parts, but we're still using this solder here. So this is fine solder wire. Part tin, part lead. SN is tin on the periodic table. PB is lead on the periodic table. So this is a 60-40 mix of lead and tin with 1% of flux inside of it, which is like a gooey liquid that cleans off out the iron, the metal contacts, so that all this stuff sticks together, and the rest of the stuff is there. So I think what we're gonna do is since we're testing this, we're gonna test this by placing this part of the board right here. Ready? Like that. And So we want to solder all this board to that board, because then it's going to look like this one, right? Yeah, because this is the same thing, the same kind of board. So we're going to make that also. And we haven't burned it yet. Ow, that is very hot. Okay, cool. So that will probably work. And none of these parts are coming loose. So I think this is a good setting here. We haven't burned this. I don't see any burn marks. I don't see any differences from this end to this end. So I think that is a decent temperature to start with. So what if we leave it right there? We set this guy down. Now the crazy part is we need to align this up very, very carefully. So what I'm going to use is my utility knife here. And we're going to kind of just like touch it like that. And line it up. Until I see everything looks straight. Just like that. Okay, cool. So now we're going to try it out. We're going to touch a tiny bit of this solder right here on the corner to the top thing, but I'm going to stab this basically because I want to hold it still so it doesn't slide around, so the parts don't slide back and forth. So let's see what happens. It's not enough to melt my solder yet. So that is not hot enough to melt the solder. Boo! Boo! So we might have to crank the heat up a little bit. And that's where the concern will come in, is that like how hot is too hot for us. And we'll have to test this out, right? So let's grab our needle nose pliers now and pull this off. Whoa. And we're going to pick that up with the needle nose pliers and we're going to set it down over here. Dun, 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 dun. So let's check the temperature on here again. Ready? 153. 153. So let's up the temperature to I don't know. Oh, I don't see it turning back on yet. And this is why we're doing the test. I think we may have melted the gear that was doing the turning. Well, that's a... I don't hear it clicking on anymore. So yes, it appears we've melted the gear inside here. So we probably can't use PETG for the inside part right here. That does feel kind of warm on the bottom. So I may take this apart over the week and find out just how it came apart for us. But since we're already here, let's try it out. Let's check the temperature again. 150. So we're hovering up right about 150, which kind of sucks. And of course everybody wants to chat with me right now. Oh yes. Yeah. Everything came apart. Right there. The gear is spinning, but it's just broken through the metal part. The metal part is hot. The gear is like hot in there. You can kind of see it right there. It's sticking out and it's hot. It's actually bubbled up my pad here. So we're going to unplug this. We're going to have to build more safety features into this part here, which is exactly why we try these things. Excellent. So we got a bubble here from the heat. It'll probably go away. Oh, yep, it already dropped down. Cooled off, bubbled up. And this obviously is like a no-go, right? So I'm gonna have to go back to the drawing board and come up with a way to adapt this. And possibly what happens is we make another stand underneath to support some of the changes in temperature. And you can see, actually the whole thing is kind of coming apart. The PETG was not the good option for material here. PETG is hotter. PETG, hi, hey, how you doing? So PETG is hotter than PLA. It can withstand more temperature, more heat. But clearly, as you can see, this is just way too hot for the PETG. The PETG is starting to melt underneath, and what I assumed was this panel here absorbed some of the heat because there was another plastic housing on it, and that is just not the case. This is also actually very hot. So if we take the temperature, if I come back over here, let's check this out. So I got you. You need a better view. So the temperature here is warm, 120 degrees Celsius so far, and the temperature on the top is 140. So that's not a very big difference. We're looking at, you can see the mark there, 137, and I assumed, I did not test this earlier, that the dark part would be significantly cooler, and it's not actually significantly cooler. You can kind of see it right there. It's 80 degrees Celsius. That's not cool enough for this part, and it feels like the what's this thing called? This the thermostat. The thermostat right here. I'm going to try not to flip it over, but the thermostat right here is actually is hotter, and it's actually melting the gear and melting through this platform. So I can like pull all this apart. It's very, very, very soft. You can see the gear, and oh, you can't see the gear inside, but it's like gooey right there. So the gear, the internal inside here, those things are the ones that are not working. So I can't use these gears, is what it looks like. I could probably use the housing, but the thermostat on the inside, the thing that turns, is too hot for this gear and this part. I'm going to set this aside over here. I've got a wood block to deal with that. So I can actually still use this. Excuse me, but I can't use it with the gears and with this thermostat on the side. I have to manually adjust it to the temperature I want, and that's going to be boring for a stream. I don't want to do that while we're all here. So I'm just going to set this aside, let it cool. And instead, let's talk about this laser. Let's talk about this laser. I'm gonna change some views here. We're gonna turn off this view. I'm gonna move me over here. Hey, what's up? How you doing? So you can see the laser now. So you can see the laser. The laser's mounted to the thing, and I think I might be able to turn it on, really. But I'm gonna take a quick break because I really gotta go to the bathroom. I'm going to play our break time video, which is... Where is that? Here it is, right here. All right, give me 1 minute. I'll be right back. Hey, what's up? Okay, back. Hands are still kind of wet. Towel's not completely dry. But anyway, so okay, so we can ignore. We're back. We're gonna set aside all the iron, hot reflow plate, all the words I'm butchering and all that kind of weirdo stuff that I can't get out of my mouth today. We're gonna go with this laser. So I don't know if anybody's ever used like an industrial type laser cutter or not, but you can see my setup here. Check this out. That white surface is actually the glass bed from 3D printer. You can see some clips holding it down. Underneath of it is just a white sheet, a white plastic sheet to kind of show some color, because underneath of it is just screws and aluminum and stuff. So it looks kind of boring. But the laser is going to reflect off the glass, and that's going to be a problem. So most of the time, most laser cutters have a pad underneath of it and it's not a normal pad. It's because laser will cut through a pad. So it's usually some kind of metal, and this is it has the effect of raising the platform up, because the laser is focused at a specific height. So when the laser is focused at a specific height, you have this like metal platform that's up higher. Usually it's a honeycomb or some kind of grid. And I'm actually gonna Google laser cutter. And we're gonna take a peek at a couple of laser cutters very quickly. And laser cutter pad. I'm gonna use laser cutter pad grid. There we go. So replacement honeycomb. Let me see if I can share this screen. There it is right there. Let's go to the other view. Let's go to the other view here. I don't want to share Chrome. I want to share Firefox. Oh, well, let's get rid of the Teams view. How about that? There we go. Okay, cool. So check this out. So what we usually see is something like that. A honeycomb steel sheet or a grid. And it looks like that. That is usually the base for a image like that, and you can see it here. That's actually a really good image. Terrible, terrible. Let's do this. No, open image in new tab. Can I zoom in on it? Nope, not gonna let me. This is not my day for for. Oh, there we go. This might work out really well. So this is a laser, a grid. You can see it's torn metal, and this is exactly what I kind of want, right? This is from Hackaday. Another place that I actually love. And this kind of looks like it's set up for a 3D printer. So we're gonna go to this website and we're gonna check it out. So a laser Z-axis table right there. It's building a Z-axis. Yep. Very, very, very cool. And that is kind of like an explanation for it there. Open source Z table. That is the picture. Yep, right there. So these things, as you can imagine, these usually sell for $400, like a table like that. We're not gonna do that. We're not gonna. I don't have that kind of. I'm not gonna put that kind of like hardware in my apartment. I have 3D printers, and I don't mind the 3D printers. But when it comes to like, this is my living room. This is like my table where I eat is not very far from here. I can't run like a CNC machine and a laser cutter and all these industrial things in my apartment. That kind of makerspace is just not what my New York City, my Manhattan apartment is set up for. So I've got an option though, and I think this might work out really well. So I needed one of these anyway for another project. This is just a baking grill, and like a rack that goes in a toaster oven. So you can see it's got these standoffs. So it sits up like, I don't know, half inch, 3/4 of an inch, whole inch, and it raises the platform up a little bit so that it's off the glass. So now I can put things on top of the laser, or on top of the glass without the the impact of the laser. So let's go check it out. Right? Let's wander over. Let's see what this looks like. So this would look like that, and it raises up. And it raises up the platform. Very cool. Very, very, very cool. Yep. And now we can do things like put this sheet down, right? So we can put this sheet down and we can cut it with the laser. I'm not going to fire up the laser yet because that's going to be another process, and I'm not prepared to do that today. But we're gonna come back to all this probably after Memorial Day. And fire up this laser. So the laser is going to happen after Memorial Day. We're going to get the laser going. We're going to cut some transparency film, and we're going to use it to spray on a sheet of copper. And when we do that, we'll be able to like melt away all the copper and leave the stuff that's been covered up by the spray. That's how all of this works. But while I'm here, I'm gonna open up. I'm going to open up Octoprint because we're going to try this out and see if the Octoprint server is still on. Yes! So here's Octoprint. I've been printing a bunch of stuff, like 6-hour prints right there. Very, very, very cool. Ooh, there's an update for Octoprint. And you can't see any of this. So this is Octoprint right here. And if you could, like, I'm going to ignore this for right now. We could actually send a G-code to turn the laser cutter on. So maybe I will fire that up super quick and give you a show for the laser cutter. It's probably out of focus and not working so well, but let me line it up over here like that, so you can get an idea of what I'm talking about. So if we're ready, I'm gonna Google the G code for the fan. Marlin fan. M106 set fan speed. And M107 is fan off. Okay. Turns off the fan. So set fan speed is 106. So if you're ready, we're going to give this a good test right now. I'm going to switch to another screen. We're going to check it out. So here's the screen with the laser. I am going to fire this up real quick. We're just going to let it shoot. We're just going to shoot the laser. And let me close some other windows here, because if things get crazy, I got to run over there and turn it off. We want to be safe about this, kinda. Like I'm an engineer, so I want to be safe about it. But I was also in the army, so I just kind of want to like shoot lasers and stuff. Yeah. Drink water, make sure everything's out of my way in case I need to go around there and grab stuff. Here we are. All right. I'm going to open up the G-code, Octoprint. We're going to take code M106, and I'm going to turn the laser on half power. So 255 is 130. And then we're going to do... Actually, I'm going to do 0. I'm going to copy that so I can cut and paste it. Just in case things go sideways. Are we ready? Let's do the laser thing. There it is. And it's not turning off. M107 turns it off, for the record, folks. So that was the laser. Now let me get up and go over and check it out and see if we actually cut anything with this. It cut a hole clear through. Check it out. Ready? Here's our screen. I'm going to share my Teams view right here. As you can see right there, it cut a hole clear through. And I can see it. In fact, if I poke something through there, I can poke something through completely. So you can see right there, we cut a hole right through this on both sides. Cool. All right. So the laser worked. And yes, the laser cut stuff, but no, the laser did not cut all the way through. Or did it? There might be a mark. But for the most part, the laser is the laser works. The laser is there. It needs to be focused. The laser needs to be focused now. So that'll be something I do in another stream because, like I said, I usually stream for like an hour on Thursday night. But that was kind of cool, right? Yeah. Let's do it again. I want to get a screenshot of that. I want to get screenshots of that. Ready? Okay, so that didn't really hurt anything. That didn't really do anything crazy. So let's check out that view again. Let's flip that over. Like that. Cool, super cool. Okay, so are we ready? I'm gonna fire up the laser, then I'm gonna grab a screenshot. Then we're gonna turn it off. M106 130. Are we ready? Give it another second because I want to get a good screenshot. Dun, 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 dun. One more second. Dun, 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 dun. M107 is the command that turns the laser off. Very, very cool. So we just controlled the laser remotely from the keyboard by using Octoprint to kind of like pass back and forth. I don't know if I can share the Octoprint screen. Oh, there's Octoprint right there. So let's try it again. We'll get a cool screenshot. Ready? And we're almost ready. Since nobody's here watching, I'm just gonna screw around for a bit. Dun 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 dun. There it is. Cool, super cool. So I've got a screenshot. I'm not going to do any live tweeting tonight. But that's basically it. That's all I got for the night. I was really hoping to be able to solder together some boards and turn on the Wi-Fi, turn on this Bluetooth module, but we'll save that for later. Something else I want to do in the future, and maybe in June I'll figure out how to do this, is to share different screens from the apps that I'm trying to write. So I'm using Flutter right now to try to build an app so that I can talk to Bluetooth devices, that kind of stuff. I haven't figured out how to share that with all these devices and screens around, so it's been a bit of a challenge. Learning how to use Twitch, the Streamlabs app, and do all this live streaming. It's been a cool year for me as a nonprofit founder and director and all of that stuff, to be able to change our program and bring our program online so that you can see some of the cool stuff we do behind the scenes, some of the cool stuff I do behind the scenes, and the more we share, the more I really would like to get other people involved. So while it's fun for me to do what I do here, we're really taking kind of a break because Memorial Day weekend is next weekend, and it's kind of a big deal for us veterans, and we'll be back in June. I might stream on Saturday. I'm not quite sure if I'm going to stream yet on Saturday or not. And judging by all this stuff falling apart, I might take a break early. So we may take a stream break until after Memorial Day weekend, and come back and find a way to get more of our team in the production of streams and things. So that's kind of where I'm at right now. I think this stuff is fun. It's going to be more fun when that laser is fully functional. Mwahaha. Just like the Death Star. But yeah, okay, cool. I'm gonna mash some buttons and go. And thank you for anybody who stopped in, anybody who checks it out. We have links in bios. We're gonna update those before we come back in June, because we've got some other programs running, like our Lift and Shift Learning Series, and I really want more veterans to be involved, and more veterans to understand that there are options like free programs like education type stuff, like masterclass certificates, that kind of mentoring, coaching, tutoring, whatever you want to call it. So if you don't see something and you're curious, go to our website, go to Twitter, find us on Twitter. All our tags are the same. We Lift and Shift everywhere. That's what we do. That's it. And I'm at 50 minutes. So like I said, usually don't stream for